Potassium chloride is an ionic compound many people have heard of, however most don't know the properties and how potassium chloride can be used. This ionic compound is personally important to me as it is one of the main compounds that make up my medication. Chlorvescent is a medication used predominantly for patients low in potassium suffering from hyperkalemia. However, in my situation, it is used to prevent kidney stones from forming, as my body possesses high levels of cysteine and amino acid. Therefore, kidney stones are frequently being formed, as my kidneys don't filter out the excess waste of cysteine. Therefore, by increasing potassium levels, the urine is able to be alkalized, resulting in less cysteine in the urine and a decreased chance of kidney stones forming. However, potassium chloride is needed for many other reasons, as it is a unique compound in structure. As you can see from the diagram and structure constructed, the ionic bonds give potassium chloride a certain structure and shape. Potassium chloride's molecular formula is only KCl. However, the actual structure of these two elements is quite interesting. As you can see over here, it is a crystalline solid structure, making it white in appearance. Even though it's a solid, it is still soluble in water, which means it can be dissolved. As mentioned earlier, it is an ionic compound and an ionic crystal. This typically means that it is a compound which is held together by ionic bonds, bonds from oppositely charged ions. Since it is a crystalline solid, the atoms are held together by strong electrostatic forces, making it very stable and hard to break as the atoms are close together. As you can see on the periodic table, chloride and potassium are at opposite ends, signifying a different charge on their ions. Chloride is negatively charged and potassium is positively charged, with the end result of an ionic compound, as each positively charged potassium is surrounded by a negatively charged ion. As you can see here, the potassium and chloride are represented, and you can see that each surround each other. However, there is no pull in either direction, as both are just as equally strong. Since potassium chloride has a crystalline cubic structure, it is able to be split easily in water, and therefore potassium chloride becomes two single elements as the ionic compounds break from being soluble. This means potassium can continue to maintain body fluid composition and help with protein synthesis, which is why it decreases kidney stone chances, as potassium is used to extract proteins as well as dissolve them. Therefore, chloride is able to also continue to metabolize sodium. As mentioned earlier, potassium chloride has strong electrostatic forces, and this is indicated by its melting point being 770 degrees Celsius, which suggests that more energy is needed to destroy the compound. This benefits potassium chloride as it can be utilized with a lower chance of being destroyed. The amount of energy absorbed or released in a chemical change is also dependent on the electrostatic forces. Thank you for listening.